Okay, so example 2, this time we've got a uniform plank. Again, spot that word uniform, it means it's the same, the mass is distributed evenly, equally throughout the whole rod. Again, it's from A to B, it's length 1.2 metres and mass 5 kilograms, it carries 2 particles. One is of mass 2 kilograms and lies at C, so this is the 2 kilogram one, which is 40 centimetres from A. You can see it's converted into the SI units already. The other is at B and is of mass 1 kilogram. The plank is supported at A and at point D. So we've got a slightly different scenario here. We've got 2 points where it is supported and D is 20 centimetres from B, which is at the end of the plank here. And it asks us to find the reaction forces acting on the plank. So again, we're trying to find a force, so therefore we need to draw a force diagram. Now, slightly annoyingly, on the other side of your page, you can see there's a blank one. So we're going to use this, but it means I'm not going to be able to refer on the screen to that diagram. But again, get out my essential equipment, my lovely ruler, and I'm going to draw that force diagram. So we're going to start with our uniform rod. And we know that we've got A and B. Now really I should make this a little bit thicker just to show that it has got mass, but I'm going to draw that on in a minute. And actually I'll put the mass on first. So I know I've got the mass here in the centre of mass, and it told me it was 5 kilograms. I know that that's halfway, so I'm going to put here 0.6 metres just to remind me, because the whole rod it said was 1.2 metres length. And then I've got my first, actually I'll go to my first particle here, which was 40 centimetres away. It's a bit of an estimate, maybe I'll just shift that along a little bit here. So 40 centimetres, and that had a mass 2 kilograms. And so I'm going to put my 0.4 metres in there, which means that I know this distance here therefore must be 0.2 metres. Put my little arrows in. So it helps me solve that little bit of a puzzle there. And again, I've got a 1 kilogram mass here at B. So that's just a little G by itself. But then I've got the 2 points where it rests, haven't I? So there's my reaction forces. So I've got one here at A, and I'm going to call that, I've gone a bit wonky there, I'm going to call that R1. And then I've got my other one at, sorry, not at B, I've got my other one here, which I was told was 20 centimetres from B. So that's my second reaction force. That's my 0.2 metres there. Again, we know this was halfway. Whole distance there is going to be 0.6, so that leaves me with this being 0.4. So I should have all my forces and weights on my diagram there. I'm just going to move my pencil and ruler out of the way. So I know in equilibrium, I'm going to use this fact that the resultant force and the total moment about any point must be 0. Because I know, going back, just a reminder back to that initial definition, we looked at the fact that if something is spinning round, if it's rotating, it's not in equilibrium and you get a non-zero moment. So to be completely in equilibrium, both of these things have got to be the case. You've got to have the resultant is 0 and the total moment has to be 0 as well. So we're going to use both of those to help me solve this problem. So I'm going to first of all look at the resultant. This is what we learned how to do first, so we'll start with this first. So I know then that the forces have got to be equal and opposite, so I've got my R1 and my R2 in that direction. And they've got to equal all the forces in the opposite direction. So that's my 2G, my 5G, and my G. So I've then got, let's just simplify that down, R1 plus R2 equals 8G. Now, obviously here I've got two variables. I'm not going to solve it with that one equation, so there must be another one coming up. So I'm going to label that equation 1 and just sit tight and wait. Because I've used my resultant force, now I'm going to look at the total moment. So we're going to take moments. Now have a think about where you would take a moment. You can take it at any point along here at all. It doesn't matter in the slightest. However, we're trying to figure out R1 and R2. So it would make sense to take moments about one of those, because I know that I'm going to be multiplying it by 0 and therefore eliminating it. So let's maybe eliminate this one here. So I can take moments about A, and I'll just add in that eliminates R1. It will enable us to work out R2 and then use this equation to work out R1. So if I take my moments, I've got R1 times 0, because there's no distance from there. If I then look at this next force, again, I'm going to take these ones just as these down ones as positive at the moment, so it doesn't really matter. We don't know what direction it would move in at all, so we're just going to take these ones as positive. This is where I start. So 2g multiplied by the distance 0.4, 5g times by this distance 0.6, R2, opposite direction, so minus R2, and again this whole distance here, so 0.4 plus 0.2 plus 0.4 is actually 1 metre. And then back to this direction, so I'm going to go back to just calling this positive, so that's g, and the distance I know is the entire rod, which is 1.2 metres, and that has all got to equal 0. So if I simplify this down, I have got here 0.8g, and then I've got 3g minus R2 plus 1.2g is equal to 0. I'm just going to whiz through this. You can have a little go at simplifying if you want to pause this, that's fine. But R2 would be equal to 5g, which is 49 newtons. So I found one of these. So I can say here that R2 is 49 newtons. Now I didn't use a ruler to underline my answer before, but I'm going to do it now because it makes it a little bit neater. You know how I like that. What I forgot to do there is say that was our equation 2. Okay, so I'm going to use this fact now to substitute into equation 1, because I knew that I had R1 plus R2 equals 8g. So I can say, right, my R2, I've just worked out there, is 5g. I'm going to shift across a little bit. So I know then that my R1 is 3g, which is 29.4 newtons. Simply multiply by your 9.8. And there we have it, both of those.